No, now it's recording. Now, and we're broadcasting. Did I click on broadcast? Okay, now we're live. Awesome. Okay,
Hi guys,
people should be.
welcome. Say hi in
Hello, everyone.
the chat and let us know where you're from.
Yes. All right, we have people here. Hello, everyone. Okay, let's give some time for people to connect to the session. Hey, Cervanti. Hey, Santiago. Hello. Tell us where you're from, please.
Hi guys.
We're collecting statistics for later. Ecuador. Hey, Leonardo. All right.
Oh, Greece. It's late there. Thank you.
Argentina, Colombia, Algeria, Mexico, Argentina. Awesome. All right, let's give one more minute and then we will start. If you have some friends that they want to join, this is the time. We have space. So tell them right now, share the link with them, and we're happy to have them here. And tell your mom,
Hi,
because your
Hugo.
mom will be
Hi,
interested in hearing
Javier.
this.
Yep, tell your mom.
Yeah.
Seattle,
Venezuela. Woo!
Leo, Peru, LA.
Peru, Argentina, Ecuador.
Venezuelan from Madrid, so it's late there.
Yeah, it's quite late there. What time is in Madrid right now? It has to be like 3 in the morning, something like that.
Yeah, something crazy.
Okay, 3 a.m.
3 a.m.
All right. Thank you for being here, Juan Carlos. All right. So thank you all for being here with us. We're very excited to have this session with all of you. We have here with us Israel Herraiz. That's the way to say it, right?
Right.
Okay. Israel works for Google, and he's based on Spain, but he's right now. He's not in the 3 a.m. weird time zone, so he can be with us right now. And so we're very happy to have you here. Thanks for being with us, Israel.
Thanks for having me. So I'm really happy to be here. So it's really an honor.
Yeah, thank you for
Awesome.
coming. Can you just
can you tell us? Yeah, you go ahead.
Oh, okay. Yeah, Israel, can you just give everybody a little context about your background and sort of where you've been and how you got to where you are now?
Yeah, sure. So right now I work for Google. I joined 4 months ago. It was really like unexpected. So thing to join Google, to be honest. So I work on Google Cloud. My job title is Strategic Cloud Engineer. And I have to confess that the work I'm doing right now, it's more like of a data engineer rather than of a data scientist. Previously to working at Google, so I was a data scientist in 2 different companies. So in Amadeus, it's a global system for airlines bookings and software for airlines and other actors in the travel industry, and also at the BBVA, a bank. It's a bank in Spain and elsewhere also. Here in the US, for instance, it has also some presence. So there I was working in a company that is called BBVA Data and Analytics, and I was actually for some time working with Fabio. I was very happy to work with Fabio, but he moved on elsewhere. So, but for a while we worked together. So my background is actually from the academia. So I was a professor prior to being at industry. I did a PhD in computer science. It was more software engineering rather than computer science, even though the official title was computer science. It was empirical software engineering, studying how people do software in open source communities. And when I finished the PhD, so I was a professor at the Universidad Politécnica de Madrid. I was teaching numerical methods, computer science for engineers, and for non-computing engineers, and statistics too. So and after that, so I started to work as a data scientist in industry. So that's more or less my background.
Awesome. And so we were catching up just a bit before we went live. And one of the questions that I was dying to ask you as you were sort of talking about things that have been going on at your current company. How do you find the difference between working in academia versus working as a data scientist? Is it more or less stressful? Sort of what, because I'm sure there's some people on the line who are considering maybe getting a PhD and going into academia. Like, what's your take on it?
Yeah, well, first, I think that's a nice way of becoming a data scientist, doing research in, for instance, by pursuing a PhD. But I think it is not required. So there are many ways to become a data scientist. So having said that, when I joined Amadeus, like fresh from being all my life in academia, because that was the only experience that I had doing a PhD, working as a professor and so on. I never worked at the company except for internships and things like those, but they were like a very short term and very specific. So it was really like a cultural shock, not only for me but also for the people who with the ones we work with. So I joined a new department in Amadeus that was called at the time Travel Intelligence. And it was the attempt of the company to try to exploit the data that the company was producing, let's say, in a commercial way. So there were data scientists, there were DevOps engineers, there were all kinds of engineers, but there were also a lot of people from marketing, from sales, product managers, solution managers, people who really had like a different culture compared to the one that I had at academia. All my fellow data scientists at the Amadeus, so we all were coming from academia, so we had really a different culture to the one that was at the company. So actually part of my work at the beginning, let's say the first year when we started the team at Amadeus, was actually kind of being a bridge between the rest of the company and the data science side, because sometimes there were, let's say, misunderstandings. So I was lucky enough because, well, my wife is a consultant, is a strategy consultant, so she has done strategical plans of all kinds of, I understand, in many different kinds of companies. So I knew how a company worked, and let's say how the worldview from other departments was, how it compared to the worldview that you had when you are only in academia, let's say. So let's say that I knew how to translate that, but it was a big effort. It was a continuous and deliberate effort to try to make the bridge between data science and other areas in the company. And I think this is essential for a data scientist, because as a data scientist, we are hired to have a impact on the business, right? So we can do really sophisticated things, good things that are impossible otherwise, but if you want to have an impact in the business, you must be able to communicate with other people who have really like a totally different worldviews of and culture. Yeah, well, I'm not sure.
That's interesting, and that's one of the hard things. I mean, that happened to me too when coming from physics to data science. And just a question here: how did you adapt to the business routine? I mean, people coming from academia, I'm not saying it's not stressful, but it's a different way of living life. And when you're in a business area, you have meetings and you have goals and you have a specific time for delivering things. I mean, how did you manage to transform the way you were working before to work in this type of scenario?
Well, to be honest, what we tried was more transforming the way the company work rather than transforming the way we work. So to adapt to the way we were, like, to the way data scientists work. So this had implications in all kind of areas. For instance, HR, human resources, it has lots of implications. For instance, for hiring, because the way a company is organized internally for job descriptions, job levels, and so on, sometimes doesn't really fit the needs for data science. So I think we were doing a lot of lobby work to try to sell how data scientists work inside the company, and because we were, like, let's say, a special department, and it was everything starting from scratch, and no one really knew what data science was about, on how to actually extract value from data. So so we had to, so we did this effort to make the company understand better how we work. And as for the data science part, well, that was also a big effort for the meetings, also for the routine of the business and so on. And it was, there was a lot of coaching to the team about the, let's say, how to communicate, how to present yourself to the rest of the company and so on. Like, I think with things like meetings and even with the basic things at the beginning, especially with the youngest members, about how the different tools that the people are used to in a business setting. So how those tools work and how to use them. So how to manage your calendar, things like those. So we could work smoothly with the rest of the company. So it was a big effort of mentoring and training. So we had these frequent sessions about how should we work, how should we approach a request from the parts of the companies, and so it was let's say a group therapy between us about how we were feeling and how we were how our interactions with the rest of the companies were, and between all of us, we did this kind of, let's say, mentoring or training to try to just at the same time modify how the company work so it worked better for us, and also adapt how we work so we could fit better in the way other departments in the company expect us to work.
So you kind of met in the middle.
Yeah, kind of. Yes.
Cool. So one of the important things to mention here right now is that, so prior to working in the business section, you were doing your PhD and teaching, stuff like that, and you consider yourself a software engineer before that. Is that right?
It is correct. So I was doing research on software engineering, and I considered myself a researcher that knew software engineering well, let's say. Yeah, so, but I was more a software engineer than a data scientist. I wasn't even aware of what the data scientist was, to be honest, at the time. So
all right, because that's the key topic of today. So if you were following the discussion until now and you register here, you remember that the topic is notebooks are not enough. So I think that's a very interesting title for a session where everyone is using notebooks everywhere. So Israel, can you explain yourself with the title, please?
Explain yourself.
Yeah, the title comes from my experience where having notebooks everywhere for everything, and really like a big messes using notebooks. So let me clarify that I think notebooks are a very good tool, like a phenomenal tool for many uses. Like, for instance, when I teach, I'm still teaching sometimes, not very much, but sometimes when I teach on technical topics, I use a notebook for that. So, for instance, for delivering a lecture, any kind of conference that has a technical content, is a hands-on talk. So a notebook is an excellent tool for that. I think it's also a very good tool to write documents, rather than to write, let's say, software. When you have to show something, how something works, like a library or a kind of analysis or machine learning problem or things like those. So having a document that allows you to execute things, to interact with the code, with the data, it's a very, very good tool for that. or to learn how something works, or to learn how some piece of data look like. So for this kind of tasks, I think notebook is very good. The problem with notebooks is that because they are so good for some things, so I think people tend to fall in love with the notebook interface, and then they try to use it for everything. You start trying to learn about the problem, then that learning process becomes a prototype somehow, and then the prototype suddenly becomes a product itself, and then you end up with a bunch of notebooks that are actually now a product. And for that, so I think using notebooks for that is wrong. It doesn't cover all the needs that you have to cover in order to have a product, and I think they are even harmful sometimes, because you think you have something, but let's say the equivalent in just one script of Python, from just to put an example, and the same in the notebook. I think the notebook has even some disadvantages over just having one file with code. So
can you define, sort of, for the people that are listening, when you talk about becomes a product, what do you mean by a product, and what are some examples of that?
Yeah, so what I mean by the product doesn't necessarily mean something that you're gonna like package and sell and so on. So it's something that needs to run in production. And for production, I mean something that it's going to have an impact on the business. Not necessarily that it's going to be like run 24/7 in a website that is going to have users, things like those, but something that the business relies on. So for things like those, you need to fulfill some extra requirements. And so that's what I mean by production, something where the business is relying on the results of your data science process. So then that's production, and then you have to cover some extra needs, let's say.
Cool. Can you guys hear me?
Yes.
Okay, I think I'm having some problems with my internet, but it's fine. What you mentioned is just very important, but so people right now are, as you mentioned, are using notebooks for everything. Mm-hmm. And what will be your solution to that problem? I mean, you can use them for some things, but when you want to deliver something and add some value to as a product, as an internal product or external product, then what you should be using? If you're not using notebooks, what's the solution for that?
Yeah, so that's a really good question. It's what everybody asks after I deliver a talk about why notebooks are not enough. So let me actually start with what do we have to do. So there are many different kinds of tools that we can use to develop a software, let's say. So there are tons of them, different technologies, different editors, different environments, and so on. So when we are doing data science, so you know that typically for data scientists that we say that most of the time that we spend in a data science project is devoted to cleaning data and dealing with data and things like those. So I think that's a very good analogy for when you have to put things in production, because the data science itself, it's what we normally call data science. It's a very small part of what the data science process that it's running in production need. So there are many more things that you have to ensure, for instance, about the quality of the software, the quality of the data. So you need to do a lot of more work so you can make sure that what you're gonna be running in production will actually work when it's like it's going to be running unattended and so on. So the solution to this is actually it's software engineering. That's it. There's no, let's say, no magical solution. So you know, when software started like 50, 60 years ago, all the problems that we are facing in many data science projects, in many machine learning projects nowadays, the people at the time, they face the same kind of problems. They suffer the same kind of problems. So they have problems with projects that were going like overtime and overcost compared to the predictions that they had done at the beginning, that were not delivering what they promised at the beginning. This kind of typical problems in that happen also now in data science. So those happen in the software when people started doing software. The field of software engineering as a body of knowledge, so has actually evolved with all this learning from the mistakes that people have done in industry. And now the processes and the tools that are recommended to for doing software engineering, so they are actually intended and designed to try to overcome these problems. So what I say is that we data scientists we are software engineers, a very specific kind of software engineers, because we need to know about data science, and data science itself is much more than software engineering, but much more. So we all know. So all the statistics, machine learning part, for instance, all the data engineering, how to handle data with big data, for instance. So all those parts, that's much more than just software engineering. But we need to apply the same kind of techniques, because what we do is highly complex. It's a very specific type of software, but also even, I would say, more complex than doing normal software. And if we don't use software engineering in a situation like this, I think it's a recipe for disaster. So the solution is software engineering. What does it mean in practice terms? So, okay, fine. I want to use software engineering for my data science projects. How do I do that? Well, there are different kinds of tools. So we should start by using software development environments for doing software. We should start by following standard practices, like, for instance, doing unitary testing in our code, doing integration testing when the system starts working with other pieces of software. For instance, when we're doing machine learning or projects and so on, so we should use standard tools for deploying the projects. So, for instance, there has been some work recently. I'm thinking now, for instance, of Kubeflow. So just as an example, so the problem that Kubeflow tries to solve is precisely this: is deploying machine learning projects in production, because the deployment of this kind of projects it's an art. So we don't have as much experience with the machine learning projects as we do with other kind of projects, and now, like nowadays, nobody really knows how to do stuff on that. How to do a proper deployment of machine learning, let's say in a broad way. So of course, like big companies, for instance, Google has been doing machine learning for long, Facebook, all these companies, but it's not, let's say, it's not a practice that is standardized. It's not something that is taught at the school, let's say. So to summarize, what we have to do as data scientists is a software engineering process applied to our software projects when we already know what we are going to do. So once we have decided the data science method, the machine learning technique that we're going to apply and so on, when we already know the data and so on, and we are going to start doing something that is meant to be run in production, then we have to apply the software engineering process.
One question here, Israel. But so when you are talking about all these different tools for doing data science that are close to software engineering, normally that's attached to a data engineering position.
Yes.
So how will work in a real time, in a real business, when you have data engineers and data scientists? How should they work together? And what's the knowledge that the data scientists should know from data engineering, and what's the knowledge from the data engineering side that they should know about data science to have this perfect combination of software engineering and testing and machine learning into a company?
Okay, so let me start by telling you how we should not do that. So in many companies, in my experience, for the places where I have worked and for what I have talked with other people who are data scientists in other companies, so sometimes there is a very clear frontier between data science and engineering in general, not only data engineering. So you have like data engineers putting data somewhere, and you are consuming that data in the data science part. then you do your prototype, and then that prototype moves on to some architecture department that will put things in production. And this engineering, science, architectural department, so it's like different departments that don't communicate much with each other, that they don't even are located in the same places, things like those. So I think that's a mistake. So data science teams must be multidisciplinary. So you must have data scientists, data engineers, product managers, UI people, like a full team working, quality people working together in teams in an integrated way. So when you are doing all this data handling or the data science part or promoting things to production, all of that is always done by the same team. So the team must have ownership of the full process, end to end, from the beginning up to production. For that, you need different kind of roles in the same team. Of course, you're not gonna find all the necessary skills in just one person. So it's already difficult to find data scientists because it's let's say like an intersection of many different skill sets. And so in the market, it's very difficult to find data scientists because of that. So you're not gonna find all the necessary skills, engineering, architectural, and so on, and data science in the same specific person, but you can do that in a team with a full ownership of how to do stuff. So on the stuff they're doing. So I think that's small teams or larger teams, but with all the roles inside the same team, with people who go for lunch together every day, who when they get in the morning to the office and start like having a coffee, they are like side by side, so they talk all day, and they know each other, they know what are the problems that are facing, they are suffering, let's say, all this.
They start to learn the language of each other.
Yeah, and the culture, and they start to understand each other because they live together, let's say. So things must be cross-disciplinary, and they must be they must retain ownership on the product. So most of the problems that I see in data science can be are caused because the teams don't have full ownership of all the stages in a project, and then you have to give something to someone else who really don't know how you have done stuff, and that they have now a different responsibility. You know, all these different responsibilities for a project are like in different places that are not deeply connected. They are not like intimately connected, and then so that's, I think, one of the main sources of problems in data science. What you have to do is to have small teams with full ownership of the full process.
I agree with that so much. I just, so first of all, the last couple companies that I've worked at as well have been very siloed. Somebody makes the data available, and then, I'm the person in the middle that utilizes that data, cleans that data, models that data, and then I pass it off to somebody else to put it into production. Yeah. And yes, I don't feel as much the pains of the getting it into production part, but the coming this way when I've scoped something and I want data available and I want it to be at a certain granularity, or I just want certain things taken into consideration. Sometimes what I get back, what actually ends up in the data warehouse, isn't what I was expecting or how I would have done it myself if I was in there doing it myself. I feel it.
But so how would you deal with that? Because I mean, if
he gave us the solution, he said it's going to be teams. They've got to be integrated and they've got to have lunch together.
Yeah.
No, I mean, that's one of the solutions. But the thing I'm wondering here right now is that you will have people in the data science team with different types of roles, because some will be senior, some will be junior, or some will be semi-senior, whatever you want to call them. But so how would you go and standardize the process? And this question is related to a different question I would like to ask, is that software engineering has methodologies, like they're famous. You have Scrum, you have Agile software, Kanban, stream programming, waterfall, all of these different things are run in the world. Right now, I think a lot of companies are trying to adapt Agile with like normal Scrum with data science. So, I mean, what is, in your experience, the best process for teaching a company on how to use a software methodology that worked for them and that will standardize the knowledge between all the data science team?
Yeah, well, well, that's a tough question. So I don't really know. That's let's say that's a $1 million question in data science. But for a data science team with different roles integrated with end-to-end ownership, about the practices and standards, I think there are minimal things that must be fulfilled. So, for instance, one of them is code reviews. So that's essential in any development project, and especially in highly complex projects like data science projects. So you must have code reviews so that you don't integrate changes without having someone else having a look at the code and giving the approval of that code. To give the approval of a code when you are reviewing, you need standards or guidelines that you have agreed on. So, for instance, standards about how you are going to code, how you are going to write source code, like minor things about the style, for instance. But it's important that everyone is following the same style because that reduce the barrier to, let's say, to comprehension of the code. So, and then having less difficulty to understand the code, it will mean less problems in the future. So that's another thing. So having like agreed code and guidelines that anyone can use in order to review the code of other people. Another thing that you must have is continuous integration and continuous delivery. So every time you make a change, that must be like a run against a battery of tests, and that must be automatic with every commit that you do. And then continuous delivery is that if you want to try that into a, let's say, test environment, so you must be able to do that just by pressing a button. You should be able to do that. In order to do continuous integration, you need of course, version control. I have omitted that. I have assumed that everyone is using version control nowadays. It's that's a no-brainer. So if you go to a company or to a project and they are not even using version control, so that's really a huge red flag. So, but for doing continuous integration, you must have tests. This means that you don't only need to write code when you are doing data science, but you also should write tests to make sure that your code is working as intended. This actually means that for a typical data science project, this will mean more work because you don't only have to do, let's say, the functionality. Now you have to write the test for that. So, and this is not a very familiar concept for many data scientists because this is something typical in software engineering, but it's not so typical in data science. And the typical reaction will be like, come on, now you're telling me that if I follow in this process, I will avoid problems, I will save time and so on, but you're asking me to do more now. But in let's say in the medium term, it will pay off. It's kind of let's say you are investing in an insurance policy. So yeah, you have to spend some when you buy insurance, you have to spend some money now. But you will, if something really bad happens, you will save lots of money in the future. So I think that is the same analogy. And of course, to do all this, you need the proper infrastructure. So you need a version control server that allows you to do code reviews and implement this process. You need to have a continuous integration server, continuous deployment. You need to have different environments, test, staging, production, and so on. All this requires computing resources. Will require engineers to maintain and set up all these systems. So it requires a lot of resources too. So. So these are our examples of what you actually need in order to have, let's say, standards. It's not about having all the written standards. It's about having a system that allows you to work in a specific way and follow that process. And by following this process, this has been studied in the software engineering community for long. So this way of working will ensure that your software has a minimum level of quality, and this will avoid problems in the future. And then, of course, there are other problems, like, for instance, data quality and things like those. I'm not entering into those things, but you need to also do like all this kind of testing. You should also do it for data to make sure that when you have like a new data coming into the system, it fulfills minimum requirements. And so you are sure that the problems that are so when you have a data science system, problems may come from different sources, from two, let's say, main sources. One is the code itself; it may have problems. The other one is the data. So you may have problems with the data, the dirty data, or a sudden change in the trends that your system was relying on, and now things are different. So you should also add testing for the quality of the data, for all the data that goes into the system, and not only for the software.
Right,
so
because if you don't have it at each point and something blows up, then you don't know where to look, just really simply.
Awesome. That was an amazing lecture, I think.
That was a ton of very useful information. A ton of useful information.
But I'm hearing right now I have in my head right now, I'm thinking on two problems we're facing right now as data scientists. First, when we go out there and start learning data science, no one tells us this. I mean, this is like a secret for data scientists. And so we're only learning a specific part of data science. I mean, we're learning machine learning and how to program with pandas, or you use the tidyverse, stuff like that. So that's important too. I mean, I'm not saying it's not important, but I mean, that's a part of your job. And the second part that I'm seeing right now is that it will take much more effort to do data science in a good way. So data science, I mean, for a lot of companies, it's like, I have some data, I want a model, please give me something. So, and now with all of this new information, we can start thinking on this is much more complex than we thought. I mean, and we need to spend time on creating standards and following methodologies and creating tests. I mean, I don't think that 80% of people doing data science right now can create tests for what they're doing. And that's a huge problem we have right now in the community, because I think most of data scientists right now are not computer engineers, are not computer scientists, are not software engineers. So this is a very big problem we're facing right now.
No, and you know what? It makes me think about it. I feel like a couple years ago, it used to be stated more that like data scientist wasn't an entry level title, right? And I feel like as we've gone on, people have started getting, a master's degree in data science, and they want to hop right into a data science role with like that actual title. And, spending a couple years as an analyst where maybe you're embedded on a squad that is developing software engineering, and you see the unit testing, you see, you're not actually doing it, but like, just by being in industry for a couple years in roles that are leading up to this more generalist, more broad, with deeper understanding in a number of different areas. Like, I don't think we talk enough about how much there really is to know, and sort of the large scale when we're talking end to end, and how to function with the business.
But I think that's normal. So as I said at the beginning, so before being a data scientist in industry, I didn't even know what data science was. So
that's true.
I was doing it, so I was a data scientist. I wasn't aware of that, or of the label data scientist, let's say. But so my point is that no one really knows nowadays, or not even today yet. So what data science really is. So we discover it as we go. All this process, for instance, I have mentioned. So this has been based in my experience, but when I started to work as a data scientist, we didn't do things this way. So it was after suffering problems, after being having to work on a weekend, like a night and day, to solve a problem in production with the customers, because we didn't put all these, let's say, measurements in practice to avoid the problems. So after all these bad experiences, we learned how to do stuff. So in most of the companies, I think the most natural way to learn all this is through it's organically through doing it. So there are not so many degrees on data science. There are not so many like, let's say, like a full degrees on what a data scientist is. So and in addition to all this software engineering part, there are so many things to learn, because you have to do, like, you have to be able to know how to solve specific problems. So what methods do you have to use for a specific kind of question, things like those. So that's really already like a very difficult job. So and I think all this is normal. So we have seen the same kind of evolution in other areas. So I'm thinking, for instance, of web development. So when the web development started 20 years ago, more or less, so most of the people were not using the same practices as standard software engineering projects. And now any web project, any web development project are following strict software engineering practices, and you wouldn't get a job as a web developer anywhere without knowing how to do that. Whereas 20 years ago, that wasn't required. So I think we are in this very early stage of data science, even today, even like 2019. So we are still at a very, very early stage. So let's say the good news for data scientists is that don't worry very much if you don't really know how to do all these things, because no one does. So but that doesn't mean that we don't have to do it. So I believe that in 10 years time from now, so when if people look at this video in YouTube or wherever, so it will become kind of, like history. So see what they think. So what they talk about 10 years ago is like, now it's basic. Now everyone knows that. So
I have no idea.
Cool. We're gonna put this in a time capsule.
So Israel,
Yeah.
I think right now we have a lot of questions for you. So I think it will be a great moment to start with that right now. And I'm gonna start from the beginning, okay? So the first question is for Santiago, and he asks, what does a prototype is and how is it made? I think it's when you were talking about prototyping code in the beginning of a process of data science.
Yeah. So I think a prototype, and this is not only in software, is something that you make and you're gonna throw away. So you're not gonna really exploit it. So if it's gonna be thrown away, you don't have to put as many measurements in practice to avoid problems. Let's say, for instance, imagine that you are doing a prototype car. You're not gonna sell it. People are not gonna use it. So only you are gonna use your prototype to test some things. Once you have discovered what you need to discover, then the prototype is thrown away. So that's the differentiation between a prototype and a product. If you're gonna do something that is potentially is gonna have impact on the business, in the sense that the same exact code is gonna have impact on the business, then that code you must take some precautions. But if you're not gonna use that very same code in anything that is going to have an impact on business and it's going to be thrown away, that's a prototype. And for instance, for that, using a notebook is fine. And not only fine, I think it's a good approach, because it's interactive and you can learn stuff and so on. And that's the point of a prototype: learning and discovering stuff. And for that, a notebook is excellent.
I totally agree, because especially when I started using notebooks, I found that I got better at explaining my code, because I had to stop, you can't just like skip cells, you have to say something about it, and it makes you think. And so, so when I think of the word prototype, a lot of times in industry, we use the term POC for proof of concept. So if somebody asks me, a lot of times those asks will look like, hey, we want to see if a cluster analysis of the base would be useful. Can you deliver something in 2 weeks? So in 2 weeks, what you're going to get is 12 variables that were easy to find. I'm going to throw it through an algorithm and I'm going to look and see if I see anything. And then we're going to throw that away, and we're going to actually spend the time to source all the data and fully clean the data and create something that's actually useful.
Totally. All right, awesome. So next question is from Harry Santana. And he asks, how do you apply ML and AI for practical uses, as management would like? Sometimes they want to know, what is the budget? What can AI really solve? Isn't this simply an extension of statistical and data modeling? How do you convince them?
Well, I don't think it's just an extension of statistical and data modeling. So machine learning and artificial intelligence enable use cases that were not approachable just by just using statistics. Well, I don't know exactly how to respond to this question. So in my experience, the problem we have had is more than convincing people to use machine learning is actually finding out about finding out what they wanted machine learning for exactly. So the problem we have had normally in the teams where I have worked is that someone came, a product manager, social manager, someone from marketing, sales, and tells you like, we need machine learning. Oh, we need artificial intelligence in our products. And then you ask, okay, so what for? So as data scientists, I think what we need to demand from other parts of the company is a clarification of the what, and then we will define the how. And it's like, what do you want machine learning for? What problems are you trying to solve? Can you describe it? Or maybe we can iterate together to try to, let's say, define the scope of the project. And then we will see how we can apply different techniques to solve it, and how maybe questions that were unapproachable years ago now are approachable because we have the tools of machine learning and artificial intelligence to solve them. So that has been the problem in my experience, rather than convincing people to use machine learning. So in companies, especially in the, let's say, in the ones that have, let's say, customer-facing products, so they are all excited about having ML power or products or systems, but they don't really know
easier,
what
right?
for. And now it's much easier because we have much more tools, we have lots of data, and in a company that has the data, so it's feasible. But the problem is more finding out what is the use case and defining the use case, so you can actually define the scope for your machine learning project, rather than convincing people that you have to use machine learning for a problem. And actually, I think we shouldn't focus on we shouldn't focus on trying to convince people to use machine learning. What we should focus is on solving problems and then using the tools that are right for the problem. Sometimes it will be machine learning, sometimes it will not. It will not be. So many problems can be solved maybe with basic statistics.
Awesome. I'm writing that down because that's quality advice. So next question from Daniel. Are software engineering design patterns applicable in data science projects?
Well, in my experience, no. So design patterns are more about how to structure software for typical architectures. For most of the data science projects, the typical architectures that we will have to use, let's say, are very different to standard software. So in my experience, design patterns are not really necessary for data science. That's because the kind of software that we're doing is different. And design patterns are, they are a very good way of designing specific kinds of software, and data science is not that kind of software.
Awesome. I think next one we kind of answer it. I think you kind of answered it before, but maybe you can mention, how do you incorporate continuous integration and continuous delivery practices in data science project? Maybe you can mention some tools right now here.
Yeah, well, so first you need the people and the systems and all that, but about tools. So for instance, in the teams where I have worked, we were using, for instance, Jenkins for the continuous integration part. For continuous delivery, every time we did a commit, so we produced a package in Python, in R, and this package was published in an internal package repository with development versions of the packages. So anyone that wanted to use our code, they just had to update their packages from the internal repositories. For that, we were using Nexus. It's a package repository system. So, and there are many different options for this. So for the package parts, you have also Artifactory, and so you have lots of systems. But basically, I think finding the tools that you need to put the CI/CD in practice is not really the problem. It's that finding the resources, the people, and the competing resources that you will have running 24/7 to be able to for data scientists to use them in the process. That's the biggest let's say the biggest problem to implement this in practice rather than specific tools. So there are many out there.
Okay, the next question is from Antonios, and he asked, software engineering wise, what are the top skills a person that has an experience mostly in machine learning must learn and develop in order to be useful to the team and company? So I kind of read this as like, if I was going to go Google and learn some software engineering stuff, what would you have me go Google?
Well, so for software engineering, I think so. The first thing I would do is I would familiarize myself with unit testing. I would try to add unit testing to the code I have already developed. I would try to learn how to do it. I would try to learn how to do that in an automatic way with continuous integration systems. I would try to install, I don't know, Jenkins or any other system in my computer in local, and I would try those out. I would try out those things. So. I think that's the first step. Learning how to do unit testing with the code that you have already done, for instance. So that would be the first step.
Awesome. One of the other questions here is.
So I think we had one question about Javier.
Before from Javier. Yeah, that's the one I'm reading. What's your advice for someone that has a business background, MBA, and getting into data science for the last 8 months?
Well, so I think the two pre-requirements are you have to learn how to program. So and you need to learn how to program well. So I would try to start learning how to program for instance, in Python. So I think Python is a very good option because it's a very broad language. So it's used in many different areas, and it's one of the top languages in data science these days. And the other thing I would try to learn is, let's say, notions of statistics. So you can understand what's behind many of the machine learning methods that are being used nowadays. So I would start by that. And once you dominate that, so you know how to program and you understand, let's say, statistical concepts, I would try to start learning machine learning with examples, practical examples, without having to code yourself the machine learning algorithms using libraries. I don't know, like scikit-learn in Python, for instance, or TensorFlow, and then I would start practicing with that. So those are the steps I would follow.
All right, next question from Anonymous. How much time? So yeah, they'd like an estimate of how long it takes to develop a small end-to-end product, and what would be the technologies you would use?
Well, the time is in specific terms is difficult to answer. But if the question is that, will all these things add more time to the project because you have to do more stuff? Yes, for sure. So it will increase. Let's say the deadline for the delivery date has to been pushed to the future because you have to do more stuff. But again, as I said before, this is kind of an insurance policy. You will save in the end. About the technologies to accomplish all these things, well, we have already mentioned some of these things. But for instance, so these days, for instance, now that I'm working at Google Cloud, if you have a code that is written in TensorFlow, machine learning code that is written in TensorFlow or scikit-learn and things like those, you have many tools in cloud providers like Google Cloud that will, let's say, reduce the barrier to put things into production, like for instance, for deployment. So deploying a machine learning model in Google Cloud is really seamless. So there are, for instance, now courses in Coursera about how to put the machine learning in production, I don't remember now exactly the names, but there are a couple of new specializations about that. So that will reduce, let's say, lower the barrier for deploying machine learning. And the technology that you need to use, well, it's standard libraries like scikit-learn or TensorFlow. And then if you are using, for instance, a cloud provider, that will reduce very much the time that you need to put things into production. Otherwise, you will have to put all the systems by yourself, up and running, and that always takes the time.
Yeah, can we talk about Google Cloud for a second?
Sure.
So you can keep your data there, right? Like
Yes.
there, and then so you're talking about modeling and deploying there as well. Just
Yes,
tell me
exactly.
about just do you want to just give me like a little light overview of sort of
So let's say you have a model in TensorFlow, for instance, in Python, just to put things in a specific way. So when you have a model in TensorFlow, you have to train the model with data, right? And to train the model with data, you normally would need like a large amount of data, so the model is good enough later on. So and once you have the model trained, you would need to do inference with the model. You would need to get predictions out of the model, right? So, and those predictions are gonna be consumed elsewhere, like for instance in an app, in a mobile phone or in your web and so on. So, in order to fulfill all these requirements, so you can, there's one product is in Google Cloud is called Cloud Machine Learning Engine. Where basically if you have a model in TensorFlow, you can upload the model in a serialized format, train the model with data that is stored in the cloud, then deploy the model in the cloud and offer that model as a REST API, as a web API to other consumers. It could be, for instance, your app or another web or a website. And then all of this is, let's say, done in a seamless way. So you just have to upload the model, define the data that is used for training, and then after a while, once the model is trained, you will have an API that is ready and up and running for other systems to use that API. So it basically reduces a lot the amount of effort that you have to do in order to, let's say, put machine learning into other systems like apps or websites.
okay, but so is it a relational database in the cloud? Like, can that be in the cloud, or it's unstructured data, or are you pulling from a server that's someplace else up?
It could be anything. So your model has an input. It has an input.
Sorry, my husband's a software engineer and he's behind me and he's just waving. He's like, it's anything. Okay.
So it could be anything. It really so it depends on how the input to your model is. So, but it would be in any format. It's let's say flexible. So the way data is structured, it depends on your model. So it depends on what kind of model you are doing. That doesn't really matter for using these services to put machine learning into production. So when you send a request to the model for inference to get the prediction out of the model, then you have to send the data in the same format that the model was expecting, but you define that when you created the model. So it's completely flexible, and it's not a kind of a relational database. It's just data in the format that your model expects, and then asking the model for predictions with pieces of data that it's structured in the same way that the data that the model was trained with.
Awesome.
Yeah.
So we have time for one more question, and we have 11 questions here. So I'm just gonna pick one question that I think a lot of people may be wondering right now is what do I have to do to get a job as a data scientist in Google?
Well, that's a tough one. That's a tough one. So I think maybe the first step, so it's kind of maybe lame, but you have to apply. So
Amen.
I didn't apply to a job at Google. So I was contacted by a recruiter at LinkedIn, and when I was contacted, I was thinking, it's like, why are they contacting me? So this is out of my reach. It's like I'm gonna be it's gonna be totally impossible for me to get a position at Google to work at Google. So in
Which is
reality, it is not.
nuts, by the way, because you have a PhD and you've done a ton of stuff, and then you add industry experience.
Yeah. So, but even with that, so
back up. You sound kind of know a lot of stuff.
So the first thing you have to do is apply. So I think we think it's kind of, I don't know, impossible, or there's this myth that it's gonna be impossible. And truth is that for many positions, it's actually kind of hard to find people, especially in data science, because the job market is now it's so effervescent. There are so many opportunities. There are not so many people, let's say, available. And the other thing that you have to do is prepare, study, and prepare. So one of the interviews that you have to do typically at Google for technical position is an interview. It's a programming interview. So, and this programming interview is kind of hard. It's not only because the problem is harder or less hard. It's because you are doing that in front of another person. You have to, think aloud to communicate with other person whether you are trying to solve and how you are trying to solve things and so on. And it's a very stressful situation where you have to explain yourself, to solve a problem. For me, I think what it helped a lot is actually lecturing and delivering technical talks where I was doing like demos live with code and coding in front of people. That helped me a lot to, let's say, handle my stress under these kind of situations. I remember when I was at university, when I started to work as a professor, I was in a mathematics department, and many people in my department, when they were teaching numerical methods or statistics in the practice classes, they started the class already with, I don't know, 30, 40, 50 lines of code with an algorithm already in the screen and already like laid out in the editor. And teaching like that so doesn't help you in these kind of situations. Whereas if you start like from scratch with a blank editor and you start doing everything from the beginning, doing mistakes in front of people, because when you're programming, you do mistakes, of course. It's like who does program like in just one pass? Like you have written one line after the other and you reach line 100, and it's impossible. It doesn't work that way. So doing these kind of things in front of people, making mistakes. Many times when I did these mistakes in front of a class, I don't know, with 100 people, is really I didn't have a clue about what was going on with the code, and I had to ask help to the students and so on. So giving talks and delivering talks in front of people of technical content, exposing yourself, let's say, to explaining technical things that are complex that you don't really know well, maybe, but you have to learn to explain to others, and doing that, like for instance, doing live coding and things like those. It's very stressful. The first time you're gonna like screw up a lot of times, but after a while you get used to these situations, and I think that can help you a lot in a process like the ones that we do at Google, which are heavily technical and always very stressful because you have to explain stuff as you are doing it to other people. So first thing is apply. Don't hesitate to apply to positions, because so we think like a company like Google is, I don't know, it's for unicorns or myths, or no, it's for everyone. So as long as you have the, let's say, the technical knowledge to do the job, so it could be for everyone. So Kristen, you said that I have a PhD and so on. So really, you should really know like my previous background and all that. So I have faced this kind of situation a lot of times. So my credentials are not really so impressive. I don't have like a PhD from Stanford or things like those. No, it's really so. And then what I discovered here at Google is that the main people are like that. So they were not really. They were not convinced that they could get a job at Google until they actually got one by like forcing themselves, going through this process.
Awesome, Israel.
Yeah.
Well, I think sadly we're out of time. It was an amazing experience talking to you. Can you please tell people how to follow you or what you're doing?
Yeah, let me try to write in the chat. So I'm writing now.
All right, at Erraiz.
Yeah. So I think these are the two ways that I normally
That's
send
a
the
great
domain.
email. Isra at Erraiz. That's awesome.
Yeah, that's my domain.
All right, so please follow Israel. He's doing incredible stuff for data science, and we thank you very much for being here with us and spending your very precious time with us.
Thanks for having me. So it has been really good experience. Thanks a lot. I never thought I could participate in a webinar like this, for instance, either. So thank you for inviting me.
Yeah, it was an absolute pleasure to have you. You shared such awesome information that we haven't touched on yet in, you know, all the data science lives that we've done. So this was truly an awesome session.
Thank you. Thank you.
All right, guys. Thank you, everyone, for being here. We'll see you next. We will be announcing the next guest very soon. So please visit datasciencelive.com to watch the previous recordings and follow Kristen and me on our different pages like Twitter or LinkedIn, Instagram, so you can be aware of what we're doing. And thanks, everyone, for being here again.
Bye, everybody.
Bye-bye. Thank you.
Bye-bye.